Today I am in Christian F. Domingo again, and I am from BSCE 3G, and I will discuss another problem uh, from dynamics of rigid body. So this is the problem. The motion of the equilateral triangle plate ABC in its plane is controlled by the hydraulic cylinder D. If the piston rod in the cylinder is moving upward at a constant rate of 0.3 meter per second during an interval of its motion, calculate for the instant when theta is 30 degrees the velocity and acceleration of the center of the roller B in the horizontal guide, and the angular velocity and angular acceleration of the edge CB. So this is our figure. So from our figure, in our problem said that the equilateral triangle, this is our equilateral triangle ABC, this B, sorry, ABC is controlled by a hydraulic cylinder. This is the hydraulic cylinder D, and our piston rod is this vertical line. So our equilateral triangle is controlled by this one, and our piston rod is going upward at constant rate of 0.3 meter per second. Then we are asked to determine the velocity and acceleration at roller P in when our theta is or reach 30 degrees. So I will consider this triangle. This triangle is this one. So our B is this one, the line EB. So here it is. Our B is equal to 0.2 meter. Then our x is this one, because from here to here it is the distance of it is the distance x. Then our y is this one, and this is that one. So this triangle is literally this triangle. So we consider it for us to know the velocity and acceleration at this point. So when we have this triangle, right triangle, we will be having or dealing with Pythagorean theorem, or x square plus y square is equal to hypotenuse square. From this triangle, our hypotenuse is b, so it is b square. Then if we differentiate it, our b square will become 0 because it is constant, because it has a value which is this one, 0.2. So the derivative of a constant is 0. So first I differentiate it. So 2x x prime plus 2y y prime is equal to 0. So as I said earlier, the derivative of a constant is 0. So I have two 2's here, so I cancel it, because if I divide both sides in 2, it will remain, this one remains 0. So x prime plus y prime is equal to 0. Then from this equation I will get a equation of the x prime, or our velocity, because velocity is the first time derivative of our position, or our x. So x prime is equal to negative y over x y prime. I have a equation here, but don't have um, I don't have values for y and x, but I can get values of y and x from this triangle, from our right triangle, because from our right triangle we will be having a value of theta, which is 30 degrees. It is said in the question or problem that we will find the acceleration and velocity when our angle is equal to 30 degrees. So going back here, our value of y here is b sine 30. Why? Because our y is the opposite side of the angle. We have formula for sine. Sine is equal to opposite over hypotenuse. So if we note it, or also equal to our y over hypotenuse is b. So our sine 30, our y is equal to sine 30 times our b. So that's how it goes. That's why I have a value of y, x prime is equal to, our value of y is, this is negative 0.2, which is our b, times sine 30 degrees, divided by our x. Our x is the adjacent sign, so same, it is 0.2, and if we deal with our adjacent, so cosine 30 will be the one we will use. Then our y prime is, it is said that our velocity at point A is 0.3 meter per second. Velocity at point A is also equal to y prime. Why? Because here our position is y, and if we differentiate the y, we will get y prime or velocity. Then multiply this by 0.k, which is the velocity in point A. Then cancel. Our x prime or velocity at point B is equal to tangent 30 times 0.3. So it is 0.1732. 0.1732 meter per second. So next is our acceleration at point B. Acceleration at point B is the second time derivative of our position. So it is x double prime. And how we will get x double prime? By differentiating this one, our equation for velocity at point B. So the derivative of x prime is double x prime. Then derivative of negative y over x y prime is equal to x prime square plus y prime square all over x, and this is negative, minus x over y double prime. This one is the ito na yung pinaka derivative nung ating equation nito. Shinortcut na lang yan, hindi na pinakita yung ating pagsasolve kung paano nakuha yung derivative nito. So moving forward, this is the equation for our velocity, acceleration rather, in our point B. So we will just have to substitute the our values. is equal to this one, sine 30 over cosine 30 times 0.3. This is our x prime. So negative tangent 30 because sine over cosine multiplied by 0.3, and it is squared because I have squared here. Then plus y prime. Our y prime is, as I said earlier, it is the velocity at point A. So it is 0.3. And it is also squared all over x. Our x is will be makukuha natin dito sa triangle na to. So our value of x is b cosine 30 or 0.2 cosine 30. So minus this one. Our y prime is equal to 0. Why? Because the velocity here is constant. It is said in our problem that the velocity at our rod is 0.3 constant. So pag constant ang ating velocity, ang ating acceleration ay 0. Ang y double prime is acceleration. So 0 times x divided by y is 0. So computing this one, we will now get acceleration at point B, which is x double prime na tangent 30 times 0.3 square plus 0.3 square divided by 0.2 divided by cosine 30 is 0.6928, or simply 0.693 meter per second squared. So this is the acceleration at point B, or our roller. The both acceleration and velocity is positive, and the positive sign shows that our acceleration and velocity is moving to the right. So next, the question also asks us required us to calculate the angular velocity and angular acceleration. So angular velocity and angular acceleration at line CV or member CV. So this is an equilateral triangle, meaning that the angular velocity and angular acceleration at this member is also equal to the angular velocity and angular acceleration in the other two sides. So knowing that, I can pwede kong kunin muna yung line AB. Pwede yun yung solving ko kasi equal naman yung dalawa na yun. So line AB, ito lang din yun, yung B natin. So first, what is our y? Our y is equal to sine B sine 30 degrees. So differentiating it, or rather B sine theta. Differentiating it, we will now get y prime equal to B b derivative of sine theta, which is derivative of sine u is cosine u du, and our u is the theta, so I multiply it with theta prime plus sine theta times derivative of b, which is constant, so 0. So this is 0. Then now I have an equation for y prime, for our theta prime, which is our angular velocity, na y prime over b cosine theta. Now substituting the values of the y prime, the b, and the theta, we will now get the angular velocity, which is y prime is equal to velocity at point A, so this is 0.3 all over b. Our b is 0.2. Then multiply it by cosine theta, which is 30 degrees. So our angular velocity is now equal to 0.3 divided by 0.2 divided by cosine 30. So I have now 1.732 meter per second na angular velocity. So next is our angular acceleration. Ano na natin na ang ating angular acceleration ay equals the first time derivative of our angular acceleration. So alpha, or our angular acceleration, is equal to the first time derivative of our angular velocity, which is also equal to the derivative of y prime over b cosine theta. So differentiating y prime over b cosine theta, we will now get y prime over b times this is sine theta over cosine theta squared times theta prime. So these three is multiplied by each other. So this is ito na yung shortcut ng ating derivatives na y prime over b cosine theta. So ito na yung kinalabasan niya. So we have equation for our angular acceleration, which is this one. So we will next substitute the values. So y prime, this is alpha is equal to y prime. Our y prime is our velocity at point A, so 0.3 divided by b, which is 0.2, times sine theta, which is sine 30 degrees, divided by cosine theta squared, so cosine square 30 multiplied by our theta prime, which is this one, y prime over b cosine theta. So it is 0.3 all over 0.2 cosine 30 degrees. So now our angular acceleration is equal to 0.3 divided by 0.2 times 0.3 divided by 0.2 times cosine 30 times sine 30 divided by 1032 square. So I get 1.732 meter per second square. So this is our angular acceleration and angular velocity at edge or member AB, and this is also the angular acceleration and angular velocity of our member CB or edge CB.